In today's lesson, we'll be learning about and practicing with percent bar models, meeting the requirements for TEKS 65B. Earlier this year, we learned about rate or ratio tables and how we might use a rate or ratio table as a tool to help us better visualize the relationship between two values. In this particular rate table, we can see that we're traveling 40 miles in 2 hours. We would expect then, as the hours increased by 2, that the miles would increase by 40. And that if that were the case throughout the entire table, we would see that if we traveled 40 miles in 2 hours, then we would have traveled 160 miles in 8 hours. That the relationship between these two values, 40 to 2, would also then translate to 80 for 4, 120 for 6, 160 for 8. A rate or ratio table is an excellent tool for visualizing the relationship between two values. Another tool we used earlier this year to help us to see the relationships between two values was proportions. We know that we can use proportions to assist us in determining the unknown value. For example, if I had 50 miles traveled in 2 hours, and I needed to know, well then, how many miles would we travel in 3 hours? I could simply set up a proportion, right? Two equivalent rates make a proportion. 50 miles in 2 hours would be equivalent to some number of miles in 3 hours. We also talked earlier this year about the 6 different methods or strategies we might use to solve for the missing value. So we see here that we couldn't use the between method because we cannot scale up from 2 to 3 by multiplying a whole number, so between won't work. We could, however, use within. We can scale up from 2 to 50 by multiplying by 25. So if we did the same thing to the 3 hours, we would learn that the unknown or missing value is 75. That if we were to travel 50 miles in 2 hours, that would be equivalent to 75 miles in 3 hours. In this lesson, we'll be introducing you to percent bars, a tool that you can use just like you've used ratio and rate tables, or just as you've used proportions. Another tool you can use to visualize relationships between two values. The percent bar is a visual representation of an entire thing. So in this case, the blue bar is representing the value of 100. The entire bar represents the value 100. 100% of the bar, the whole thing, has a value of 100. The same thing is true of the red bar. The only difference is that the red bar has the value at the top of the bar, 100, and the percent at the bottom of the bar. But 100% of this bar still has a value of 100. It just may be that sometimes I see the value on the top of the bar, other times I may see the value at the bottom of the bar. The blue and red bars are showing you the same data. They're just showing it to you in 2 different ways. So I've already shown you how we've used ratio and rate tables as well as proportions in order to not only visualize relationships between two values, but more importantly, to help us solve a problem, to help us identify a missing value or an unknown value. So now, how might you use a percent bar to do the same thing? Well, if I had the following problem, 50% of our 40 students scored a 90 on the test. 50% of our 40 students scored a 90 on the test. I could use a percent bar to help me identify the unknown number of students. I know, for example, there were 40 students in the class. So those 40 students would represent the entire value of the percent bar. The entire bar has a value of 40. 100% of this bar has a value of 40. 40 students represent the entire class. Well, the problem said that 50% of the 40 students scored a 90. So I could place 50% halfway on the percent bar because I know that 50% is 1/2 of 100%. So I put 50 at the halfway point of the percent bar. I now need to figure out which strategy can I use to identify the unknown number of students. Because 50% of the students scored a 90, that's fine, but I need to know the actual number of students. So I have a few strategies available to me. First, I could simply recognize that 50% is half of 100%, and therefore half the students scored a 90. So half of all the students, if all the students were 40, half of that would be 20. If I didn't notice that relationship immediately, I could then default to one of my proportion solving strategies. Maybe I do notice that I can get from 100 to 50 by dividing by 2. This would be the between strategy. And then if I went from 40 to x, I could also divide by 2. And 40 divided by 2 is 20. Maybe I didn't see that connection or relationship right away. And I instead thought, you know what, I'm going to use cross products. I could take the 50 and the 40, that diagonal, and multiply them. 50 times 40 is 2,000. And then divide by the remaining number, the 100. 2,000 divided by 100, well, instead of doing the math, I could just simply move the decimal 2 times to the left, and I would still get an answer of 20. I used the percent bar to help me visualize the problem, to visualize the relationship between the values, and then use the proportion solving strategy to determine the unknown value. So if 50% of the 40 students in class scored a 90, then 20 students scored a 90. Now, what happens if I have a slightly more complicated problem? On this screen, I've drawn a percent bar that represents 100% as an unknown value, where 60% had a value of 36. Here was my problem. 36 students chose pizza for lunch. Those 36 students are 60% of the class. So if 36 students are 60% of the class, then how many total students are there in the class? So I see right away it would be difficult for me to use the between strategy because 60 to 100, I can't get there by multiplying or scaling up by a whole number. So between is not available. I could do cross products. I could multiply 36 times 100, that would give me 3,600, and then divide by the remaining number, 60. And if I were to do that, I could find a solution of 60. There are 60 students in class. Now, maybe I don't like to use cross products because I'm not confident with my multiplying or dividing. Or maybe I always remember to multiply but oftentimes forget to divide. Maybe I just didn't notice the ability to do that. And instead I decided, you know what? I think I could scale down and then scale up. In other words, I could solve this problem in 2 steps rather than 1. So instead of using cross products, maybe I look to see if I can scale down. I see that I can't get from 60 to 100, but I could go from 60 to 20 by dividing by 3. So that if I divided 36 by 3, I would get 12. Now, I don't need 12. I need the unknown value for the entire class. But now I also see that I can get from 20 to 100 by multiplying by 5. I couldn't go directly to 100 from 60, but I could scale down from 60 to 20 and then up from 20 to 100. And so if I scaled up the 12, also by 5, I would find that 12 times 5 gives me the exact same solution of 60 students in class. A percent bar can be a particularly useful tool when we're looking for more than one unknown value. So as you can see here, I've drawn a percent bar. I've shown a value of 36, and that 36 represents 60% of the total. 60% of the whole thing is 36. My problem wants me to find the value of 10%, 30%, 90%, and 100%. I'm going to use a percent bar and my knowledge of proportion solving strategies to find all 4 of these missing values. I'm going to start at 60% because I have a known value, 36. I know that I can work between from 60 to 10 by dividing by 6. If I divide 60 by 6, I get 10. So if I divide 36 by 6, I get a value of 6. I then know that I can scale up from 10 to 30 by multiplying by 3. And if I multiply 6 times 3, I get a value of 18. I can use the same strategy to get from 30 to 90. I can scale up from 30 by multiplying times 3 to get to 90. And if I do the same thing to the 18, 18 times 3 is 54. Finally, I know that 10 can take me to 100 by multiplying by 10. And that, in fact, the value of 10%, 6, times 10, would give me the value of the entire bar. 100% of the bar has a value of 60. Percent bars are simply one more tool that can be used to help you to visualize relationships between values. They simply help you to see connections that you can use to solve problems. You can draw a percent bar to set up proportions to identify unknown values by trying to find parts of the whole, or by using what we know about the parts to find the whole. Percent bars are a great way to visualize relationships to help you to solve problems by making connections.